Okay. Okay.
So for like summation and then x plus 7, would you just add 7 to each of those values?
What did it say? X plus 7?
Yeah. The summation. Yeah.
Summation.
So you just add 7.
So you add 7 to each of the x numbers and then add them up.
Okay.
So that would be 2 plus 7 and 4 plus 7 and 5 plus 7 and 2, 4, 6, 8, and 10, and then the summation.
So that's also 65.
Does it come out to be 65? I don't have it memorized.
Okay.
Actually, I think I have it here. I think I have the answer key. It comes out to 65. Yes, that also equals 65.
So the only weird one, I wondered about was number 5.
Yeah, I was gonna ask about that one.
Yeah.
It's subtracting.
Negative number?
Oh, the y minus 2?
Yeah.
The x minus
No,
y.
x
Oh,
X
that's
minus y.
Yeah.
So it's similar to this one. We're going to take every xy pair, but we're going to subtract them in the order of x minus y. So the first pair would be 2 minus 3. And the next pair would be 4 minus 5 in the order x minus y. And then we're going to summation them. So then we're going to sum. So the first pair, what do we get for the answer? Minus 1. The second pair, what do we get for the answer? How many pairs do we have? 5 pairs. So we add up, we sum up all those -1s, so that comes out to be -5. This is the hardest math we do in this class, pretty much. This is not a hard math class. This is a scientific research statistics class. People find out, oh, you're a statistician. That means you must be really good at math. No, not necessarily. No. Okay, for those of you that just came in, because classes just started, I am like really, really grouchy with technology at the moment. So some things. Number 1, I finally got your recording up. That was the 3rd time I made that recording. And it took me approximately 5 hours to get it uploaded. As you see by the time that I send the announcement out was after midnight, right? It took forever. So Kaltura crashed my computer, and then it restarted, and then it uploaded for 2 hours and never got finished. So I had to re-upload it, and you'll notice that the final upload that I got uploaded, let's see if I go to Canvas, in Canvas, if you go to your media gallery, we'll have the last week's classes, and there is now this homework 1R portion. This does not have the picture-in-picture. It only has the audio and the screen. It doesn't have my face down in it, because at that time I was just, that's as good as I could get it. Because it saves them as 2 separate MP4 files, and anyway, that's what we get. So I have made an appointment with the university office that is over all the software for Canvas and distance classes and the recording tomorrow morning at 9 to meet with Neil Legler to figure out, because I can't even open Kaltura, the recording software, on my laptop anymore. It will not. I can click it as much as I want. I can right click and open. It does nothing. So I have found a new recording software, and it's recording right now. Fingers crossed it works. It seems to work. I just installed it. And I am going to create a YouTube channel that I post all these to, because I am tired of the university system leaving me high and dry. There's a chance I might change to a different software to make the recordings, but I will put them on YouTube. It'll depend on my meeting tomorrow. But I will keep making recordings, and they will be linked somehow on the Canvas page, and I'll send out an announcement about where and how you can find those. So my plan is to still record. I just got to figure out a better method because it's not working. Second thing, homework 1, for some reason, Canvas decided, even though it wasn't due till 11:59 p.m. tonight, that it turned everyone's in at some point this afternoon, around noonish. I do not know why, because in all of our testing, when the due date came, it didn't automatically submit everyone's assignment, and it wasn't even due. So I don't know what in the heck happened. I cannot figure it out. So what I am unable to, once the assignments are submitted, to let you back in. All I can do is grade them. So what I did is I went in and gave everyone 2 more attempts on that. That's something I can do. But I don't want you wasting your time going and refilling it out. And I know not everyone got it done because I can see what you did submit or Canvas submitted for you. So I'm not going to score all of those items. We went through most of it in class. I do want to see your R PDF to make sure that that's okay. So I shoved the deadline till tomorrow, moved it again. So I want you to go into homework 1, and at the bottom it now should have a button that says retake the quiz. It says that you have 2 more attempts. Push the retake, but scroll all the way to the bottom, skipping all of questions 1 through 11 just to get to the very last one, and upload your PDF that you knitted in Word or knitted in R, and I will just look at that. And then it'll be full credit as long as you get it turned in. Yeah.
At some point, could we just do maybe 1 or 2 of question number 12, which is
Yep.
just the round?
The R part, yeah. So I'll show you. So when you go into, it won't because I'm not on. Anyway, you just go into homework 1 and resubmit it. So let's look at that. I've got it pulled up in R right now. If you want more full explanation, you can watch the recording. It's great. It's grand. I started from the very scratch, the very start. So that recording is an hour long, but the first 30 minutes are basically what we did in class last time. So you can skip to minute 30 if you were good with what we did last time. So we got to, let's see, we created new factor versions of our categorical variables in class. Is everyone good with that? Creating new versions of factors that have the labels attached instead of being number versions. Okay, that's where we left off. Okay, so the number 2 is where we didn't get in class last time, right? So that dply or mutate statement can be used to create new variables by making factors of original variables. We can also do math. So I can create a new variable. So the way we start with the data set from the question before. We're going to save it as a different data set because we're doing 1 step at a time. We're just writing 1 sentence. And here, we're using that mutate function in the dplyr package, and we're going to create a new variable that's equal to the old math quiz variable, but we're going to give them 50 extra points. So we can use the add symbol to do addition. Novel idea, right? No, so this new variable for each person should be their original math score plus the number 50 onto it. And so when we do this, df2 should be identical to df1, except for it's going to have this new variable appended or added at the end, where everyone's value on math quiz P50 should be whatever their original math quiz was plus 50. Okay, so is this one, we good with that one? So you can do plus, you can do minus. How do we do multiply?
Asterisk.
The asterisk, asterisk in a code chunk means multiply. What does the asterisk do outside of a code chunk in the text area? It does a bullet if you do 1 asterisk in a space and then start typing. Or if you put 1 asterisk before and after paired up, it'll do italics in between, and 2 will do bold. So the asterisk gets lots of jobs in our studio. And how do you divide? A little slashy, like a fraction slash. Okay, so then this was something new I threw in here. dplyr has a command called select, and this selects some of your variables. So if we want to print out our data set, but we don't want to print out all 20 whatever variables, we just want to look at 2 of the variables, you can select and choose which variable. See, it's only going to show us just those 2 variables. And head just shows you the first 6 rows. Head, first row. What's the command for the last few rows? Tail. So head and tail. If you just do head and tail just by itself, it defaults to showing 6 rows. You can put inside this parentheses the letter N equals any number, and that's the number of rows it would show you. So sometimes this is a process of selecting variables and showing some of the rows. That's a good thing to do to make sure your variables you create are really doing what you want them to do. Because sometimes when we're coding, we don't want things to be invisible. We want to be able to check our work because code doesn't always do what we want it to do. It does exactly what we typed, but we don't always know what the computer intends to do with that. The language is important, so this is a way to check. So this one was creating a new heart rate variable that's divided by 60, so we use the slashy fraction divides. And here I use tail with n equals 10 to show the last 10 rows. And notice how many pipes do I have in there? 2, because I start with the data set, do something.
You have to do that.
What would happen if I didn't do n equals 10? It would show 6
Well,
rows.
I thought when I did it, I just put 10 and it showed 10.
Yeah, okay, so this is something I didn't show you, so this is great. This is something that is so great in R. So we've used the package tab over in this lower right-hand window, right? We use that to install our packages. Right next to that tab is the help tab. I want you guys to click on that. Help in R is actually helpful. So yours will look like something like that probably. Is that what yours looks like the first time you click on it? So there's a little search bar right here. It has a little magnifying glass. In there, I want you to type tail or head, one of the two. They have the same help page. And then hit enter, and it will bring up the help page. Every function in any package in base R or in CRAN has to have a help page. That's a requirement to have a package on CRAN. So they're always laid out exactly the same way. Up here, if we're going from top to bottom, we have the name of the function and what package it's in. Head is in the utilities package, that's part of base R. And it says this is our R documentation. The name of the function is return the first and last part of an object. First or last, because there is head and there is also tail. They're both, they're like twins functions, just top versus bottom. And then it says, gives you a description and then the usage. In the usage, it shows you how you would use that command. So head, and then we have to do the head of something. With the pipe, it's flowing from above. So we're going to do the head of whatever we piped above. So we have this data frame, we're going to do the head of. And it says ... That means there's additional options. The first option is n equals. So back when R programming first started, we had no autocomplete, and programmers are nothing else, they are lazy. And so R functions in the parentheses, there are usually options you can use, and if you don't type the options, there's usually a default assigned. If we look at this, what's the default? N equals 6L, 6 whatever it is, 6 lines, 6 elements, 6 of whatever it is. So the default is to give a 6. So if we say nothing, it's going to do 6. But if we put a number in there, it will override that default. Now, the order inside those parentheses is important. If we're lazy, we can just if we put a number, it's going to assume we meant it for n, because the data set flows to the beginning of the parentheses. So this X here is whatever data set is flowing from above. The pipe always flows to the front of the parentheses. So this X, or this object we're going to do the first or the last of, is coming from the pipe, and then the next number in there is going to assume is n. Now, yes, you can be lazy and just do tail parentheses 10, and it will work fine. But it's good to get in the habit of saying n equals 10, because somebody who sees that function might not be familiar with it and know that n comes next. The other reason is usually there's lots of options, and sometimes we want to leave the first one, we want to change one of the later ones, and if we type something in the parentheses, it's going to assume that it's the first option, not one down the list. So if you say n equals 10, then it knows it's n, and it doesn't have to guess that it's the first option available. If you scroll down in the help page, the next section says arguments. These are the things that go inside of the parentheses of the function. So n has to be an object. That's very vague. N is a single integer. What's an integer? A number? It could be negative, right? What would it do if you put negative in there? Tail just is like negative means starting at the bottom. So tail is just head. of -6. How it works. And it says rows for a matrix or a data frame. So if our object is a matrix or a data frame, it will give us rows or lines for a function. And negative is the last instead of the first. So that's why tail is the same function as head. It just assumes you're starting from the bottom instead of the top. And then it will give you details about what the function does. And then the last thing, or towards the end, after that, it says values, what it gives you. It gives us an object, usually the same kind of object as X. So if we started with a data frame, it's going to give us another data frame. And it will tell us who wrote the package, and it will give us some examples. Every function has a help page that's laid out just like this. And the helpfulness of it depends on who wrote it, but they're usually pretty darn good. Okay, so that's something we wanted to do. Okay, 4. 4 had a, yeah, question.
My
Oh, have you closed R Studio and just opened it back up again? Yeah, okay, so this is, you're not the first one in the class to have this happen. So if you look on your, if you just open our Studio, what's in the environment? Nothing. That's why it says, I don't know what the pipe is. Pipe is not in base R. The pipe is coming from tidyverse. So when you close R, it like wipes everything clean. So if you open it up again, you need to rerun all the code before you get here. So there's 2 ways. Either you can scroll up to the top and find each chunk and push play, you can do, or that's where the second button comes in handy. So next to the play button, if you hover on there, this says run all chunks above. So if you click on that button, it'll go to the top without scrolling, and it's going to run every chunk until it gets to here, and then when you push the play, this one will work. Let me know if it works.
Yes.
Yes. Okay. Good question. It's a great question, yeah. These are all things that, how would you know this unless you asked? Maybe if you poked around long enough, you might accidentally figure it out. These are the kinds of things I welcome you asking about. So in 4, there's 2 different variables we're going to make. One adds 2 before multiplying by 10. The other one multiplies by 10 and then adds. So order of operations, you might have to use parentheses if you're doing multiple steps of math. Anyone have any questions about those 2? Okay. All right, so this is the one that we had. Who saw the discussion post about this one? Yeah. Who had the same question before that? Did anyone else have that question? Yeah. So in this question, you're supposed to make 2 versions of the anxiety variable, where we add up the baseline anxiety, the pre-quiz anxiety, and the post-quiz anxiety. So they had anxiety measured at 3 different time points. And we want to add all 3 together to get a total anxiety score. So one way you can do that is using the 3 names of those variables and putting the plus symbol between them. Another way is to use the sum command. What does sum make you think it's going to do? Add them up. Yeah, sum, add them up. So I asked you to do both of them because I wanted you to see what happens when you do it. So this angst plus is where I've added them all up. So this is where you can check to see if your code did what you thought it should do. So the first person had scores of 17, 22, and 20. Does it add up to 59? Yeah, it does. I had to check. 17, 19, 16, yep. This with the plus sign is working just like we expected. But what about the sum command? What's going on there? It's summing everything. Instead of just summing the row for the one person, it's summing all 3 scores for all 100 people, and it's putting that same number in there for everyone. So this is an example of sometimes you can use a function that sounds like it's going to do the thing you want, but if you look at it by doing the head or tail, you can see, that's not what I expected, that's not what I want, this is not the right way to add them up to get a person's total. And that's because the sum command does the sum for everyone, not a row-wise sum. So there is a case where you might want to do that. What if each line was a store and each column was a month? You might want the grand total sales for every week for every store grand total. I mean, there's times you might want to add up everyone's at all time points, but probably not.
Sorry, can you go back? What's the problem
With this one,
yeah,
it says 5741.
no, I mean in the code.
In the code, it's using the sum. We didn't code it wrong, but that function sum, and I can do the help page on it here. Sum. Sum. So sums all of the values, not for each person. It's going to add them up for everyone. So it's the wrong command to use if we want person totals. If we wanted all of the totals for all of the people all totaled up, then it would be the appropriate one. It's not that I coded it wrong, it's just not the way, it didn't do what I wanted it to do if I wanted person totals. A different total for each person. And the same thing with the heart rate, except for the heart rate was the average. So we could do the average by doing the plus symbol to add up the 3 heart rates and divide by 3. Or there's a mean command. The mean command and the sum command, those are out of base R, and they do it for the whole grid of numbers, not just across each row. Yeah.
Is it possible so when you want to some
Row sums and row means.
is it
Base R does not have a command for row sum or row mean, but Tyson's furniture package does, and we will be using it later on in the semester. There's a lot of times when you will want to average or add up different variables, especially in sociology where you're giving a lot of items or ledgered items, you want to find the sum or the mean score. So doing a row-wise sum and mean is very frequently done, but the plain SUM and MEAN, sum and mean commands are not the ones you want to can use to do that. Okay. And we can use the last one, we found one of the difference between these two stat quizzes, and difference is subtract, so you can use the subtract symbol. So any questions before we get to 12, the last one, or 6, I guess it's 6. Okay, so for all of these items, on each one, we've done one step and saved it as df underscore a number, and then we're just doing one step at a time. And I did that because we wanted to focus on one idea at a time. But in real life, what that does is how many data frames did we make? 0, 1, 2, 3, 4, 5, 6. We've created a lot of different data sets. And you can accidentally choose the wrong one. So it's better to do this all in one code chunk all at once. It's like writing instead of writing one sentence, we're going to write a long run-on sentence. So that's this last one. So we can combine all those steps into one saving command. So we don't have these intermediate data sets saved along the way. The other option, and this is what we usually do in real life with wild data, is we read it in, and, the pipe means and then we rename the variables to lowercase, and then we make all of our factor versions, and then we do our mathematic steps to create new variables. And we might want to do some other steps after that. But the idea here is that we can make this pipeline of steps, combining all of the steps by having pipes between each step. And we don't have to stop and save along the way. We can do it all in one run-on sentence. But the problem comes is you cannot have a pipe after the last one because it's going to be waiting, like holding its breath for what's the next step. This will run, but the next code chunk will have problems because it's still waiting.
So if there's not a pipe at the end, it just assumes it's the end.
Yes. If it doesn't see another pipe, it thinks you're done.
And if you have a pipe, if you'll notice on the side, the left side where the row numbers are, if you put a pipe in and then you move down a row and you don't type anything, it like puts a little red dot. At least it was for me earlier.
I've got to run everything above. I just turned on our studio. So I'm running everything above. Got this. Okay, so here. Yeah. Here, I'll run this so it does it correctly. Yeah, so if I come down here, also look, I just deleted that last parentheses. So my parentheses that opens right here doesn't have a closing partner, and I get this little kind of flag alert like something's not right here. And the same thing happens, like you said, if I have a pipe on this last line. Now it doesn't do it immediately. It gives you a second to think about, are you going to keep going? But say I move on. If it sits there for a second, it's going to say, you didn't finish typing this, and it will put the red X there as well. Yeah.
When you did the deleting of the pair of the parentheses,
Mm-hmm.
there was like a tiny little red highlight underneath the first parenthesis.
Yes. Can you see that? Can you see that little? It's got a little like jagged underline. That's an indicator. This is new. This has only happened in like the last 9 months that this has been added to our studio. They added the flag a little while ago, and then there's this red zigzag underline, and that helps you find what's wrong. So it says, here's a parentheses, and we don't have it knows that it should have a partner. Back in the good old days when I started learning R, there was no color coding, there was no autocomplete, there was no alerts. You guys have it good. And this is what's helping make coding in R more accessible, is these little things, because these things will drive you bonkers. You know, what is it? One of the things is my sausage fingers will sometimes hit a period instead of a comma. If you have a whole page of code and you're trying to find what's wrong, how easy is it to spot a period that should be a comma when it's all black and white? You can spend an hour like, if you ever have code that is not running and you're like, I think it's right, this should be right, I can't find anything, what should you do?
Help.
Huh?
Find, look for help.
Yeah, what if you've looked for stuff and you just, everything you know how to do has not helped you find the mistake? Ask me! You can email me and do a screenshot or highlight and paste your code, put it in the discussion board. If you can help somebody else in the class find their mistake, guess what? You're less likely to make that mistake yourself in the future. And I tell you, spelling, capitalization, periods and commas, parentheses, pipes that are missing or going nowhere. 90% of the time, that's the mistake. And it's good to practice looking for those things because you can start to find them faster. And that's why I like lining things up, because it helps me. And now the autocomplete with the quotes and parentheses, it helps you find these mistakes faster. Do not spend an hour looking for something on the same code chunk. Wave the white flag, send a message out on the discussion board or to me, and move on with your life, whether that's the next question or something else entirely. The best debugger is a good night's sleep. It really is. Sometimes you just have to walk away because you'll go crazy. Okay. It's not that bad, but it feels like that sometimes, and that's a normal feeling for any programming, any language. Yeah.
When in Python, it'll do the little X thing on the line, but it won't do the little
Doesn't do the
highlight.
underline. Like I said, this is one of the newer, and this is our studio, not our studio. The company programmed that in one of the, like maybe 2 versions ago. It's very new. It's very handy though.
So when there's R books out there, if it's by a conglomerate, then who's publishing the book? Just anybody who wants to, kind of?
Anyone who wants to.
Okay.
Anyone who wants to can publish a book in SPSS. I think. Okay. Knit it, submit it. Good. All right. We get to continue on. Okay, so other new things. Anyone notice anything new about our homepage? I sent an announcement out about it. We now have a new website for our class, and I made a new logo. This website is fully written in R, in our studio, and hosted on GitHub. That little hexagon sticker I wrote in R with R graphics that I'm going to teach you how to do today. not the sticker, but the box plots, all of that is in R. I like R. Okay, so here I have the syllabus is linked here, and here I put all the chapters and the links to slides. Now, I haven't put all of them up because I'm going to be editing. I will try to get a chunk of these done in the next week or two. The slides are created. I just want to adjust them a little bit. You'll notice some of these old ones are PDF and PowerPoint. They will all be HTML eventually. Okay. So we've kind of gotten into the basic stuff. We did variable scales, rounding, and summation. Now we're going to do plots. Yeah.
Okay, so the PDF, PowerPoint, but the HTML in addition to the videos. Is that right?
I will be. These are the slides I will use in the videos
Okay.
if I do a video. So whether it's class video or after class video, I don't know. Eventually, I want to have all the lectures on video outside of class, and then we can just have homework time in class. But that's not going to happen until this summer. Just getting to that point. Visualization. Okay. Always plot your data first. No matter what project you're doing, how long you've done projects, how well you think you know your data, always plot your data first. Always. One variable at a time, then two variables at a time, and so on. I cannot stress this enough as a statistician. Before you can go to any fancy technique, you must understand your variables one at a time. And no matter how clean you think your data is, you will find errors and unexpectedness. I was on a project with a memory study. Chris Corcoran, the department head of the math stat department, ran some analysis. We were getting ready to write the manuscript. It seemed really, really weird, and we just kept going back to this result. And it just didn't seem right. He's like, I know I wrote the code right. And he went back and double checked. Well, in that data set, missing values were stored as 999. And it was an SPSS, and it was not defined as a user-defined. He read in SPSS, it was marked as a user-defined missing value, but when it got read into SAS, I think he was using, it lost that designation. And so these were like scores that were between 10 and 50, and some people were counting as 999. It was not functioning as a missing score. And so nobody did anything wrong, it just slipped through the crack. If you had plotted your data, you would have seen a nice histogram, and then this weird like set of 999s out here, and it would have been like, we've got to delete those first. If you plot your data, you will find things you didn't expect or extreme values that will highly influence everything that comes after. So they'll help you find impossible and outlier values. This can also help you decide which statistical approach you need. Some statistical approaches require your variables to have a normal distribution. Some don't. How do you know if your variable has a normal distribution? The best way is to plot it. Better than any of those p-value tests. Also, assumptions and diagnostics after you fit a model require some graphics, and it helps you find new relationships that you might not have anticipated. It's so important to know how to plot your data. And this is one of the biggest strengths of R. R is the best software for making graphs out there, bar none. SPSS, I would say, has one competitor for worst place, and that's Excel. Excel is the worst. SPSS is a close second worst. SAS is in the middle. There are like GraphPad Prism is kind of okay, but the great thing about R is it makes high quality graphics with great defaults, and you can do it very quickly in the same environment that you're doing your analysis. Thanks to Hallie Wickham and ggplot2. Okay. The idea with any graphical, now there are two reasons generally that we make graphics, plots, and visualizations. The first is for us to get to know our data and like during the working process. And then there are graphics and visualizations we use to present our data to an audience. If the audience is you and only you or your team that's working on it, the quality is not really that. You don't have to spend a lot of time on the plot. But if you're going to present a plot in a manuscript, a website, poster, something, it needs to be the most informative way you can present it. You need to communicate the results. It often takes a lot of tinkering with the plot to make it worth 1,000 words. Every plot is not worth 1,000 words, but it can be if you spend some time on it. Now this figure here was on CNN. Can anyone figure out why this is a misleading plot? They talked about it in the text. First of all, what kind of plot is this? This is a bar graph. How do you know it's a bar graph? It has bars, but why isn't it a histogram?
They don't
They're
match.
separated.
Yeah.
They're separated bars, then it's a bar plot. Plus, what's the axis over there? It's going from 53 to 63. This is percentage of the population,
Oh, geez.
or it's like a frequency. Bar plots should be based on frequencies, whether that's a count number or a percentage or a proportion number. So
That's not frequency.
but it's a percentage or a proportion, so it's just it's okay, because it's frequency, yeah.
So for me, as a consumer, if it was from 0 to something, then 54 and 62 would look a lot closer together than they're being represented there.
Yeah. Bar plots should always have the axis go down to 0. And the reason is when you look at a bar plot, what is conveying the information? The height of the bar. You're comparing the heights, the shaded in, so they should be the same width. That's kind of a law. And the height should show the frequency. And if they're not going down to 0, they're not necessarily proportional to the area. So what does this plot make it seem like? I know you can't read it very well, but generally.
Just that there's like a huge difference.
It looks like there's a huge difference. The first bar is a lot bigger than the other 2 bars. But here it is remade so it goes down to 0.
Oh, wow.
Bar charts that are frequencies, percentage, or proportions must go down to 0 or else they're misleading. Some software programs, you can make them that way. Don't do that. R will never do it. R will do it the right way. Yeah.
When you're doing a percentage, does it, and we know because if it's a bar that we have to start at 0, but do we have to go to 100 usually?
No, you don't have to go to 100, but you have to start at 0. In fact, I would have only made this one maybe go up to 70.
Just for room?
To say, yeah, because that's a waste of space up there. It's not, and it doesn't break a law. I mean, there are no stat police that are going to jump down and hold you hostage, and arrest you. So, some other key points. Any graph, should match the measuring tool that you're using. So if it's a percentage, usually we go from 0 to 100. We should keep it the units. If we're doing number of people, like it was number of people, should we put 2.5 as one of our labels? No, because that makes it seem like we could have had a half a person. All of our axes should be labeled. So that last plot should have said percentage of sample, or it should say percentage. It wasn't labeled there. Our caption should clearly tell us what we're looking at. And these last 2 are highly important. I preach this everywhere. I gave a talk to the College of Science, College of Agriculture in December. Preach this, preach this, preach this. Simplicity, clarity. You want to convey a message with your plots that you're publishing, and you don't want to let anything get in the way. Chart junk is like, if you look at almost any newspaper, their plots have 3D pie charts and pictures in the background, and instead of bars they use like piles of books. That's chart junk. Don't do it. It's not scientific, it's misleading.
What about color when it comes to that?
We'll talk about color as we go along. That's a good point. Yeah.
In the previous plot, I didn't really need a plot because it was just 3 values.
Yeah, if you have 3 numbers, do you really need a plot? You don't have to, no. I would argue you shouldn't. You don't always need a plot.
And also the width of the bars does not convey any information.
Yeah, so we do sometimes we do what's called a lollipop plot where we put a dot at the top and just do a line up to it.
Yeah, that would have been better.
Yeah. I'm not a huge fan of bar plots in general, but they're a lot better than a pie chart. The only time you should use a pie chart if you're showing parts of a whole. And you have to be very, very careful. Never do a 3D plot unless that third dimension shows something important. If it's just to, be chart junky, don't do it, ever.
What
Yeah.
about like a third variable?
If there's a third variable, I have published 3-dimensional plots in a journal before. Sometimes they're called for, but it better convey a third variable. It shouldn't just be to make it fancy. Yeah. And you have to be really careful with 3D plots. They're problematic. But sometimes they are called for, but don't do it just to be fancy. Okay, so this last one, like you said with color. If you can get away with it, black and white and grayscale is better. Especially because of things like color blindness. Is anyone in here colorblind? I have never had a class without at least one person being colorblind.
Maybe there is, they don't know it.
They don't know it? My niece, my sister didn't know her daughter was colorblind until she was like 11. And they didn't even, she's like, you're not colorblind. No, I'm not colorblind, but when they did the test, she was colorblind. The girl didn't know it, her mom didn't know it. In girls, it's rare, but my brother-in-law is colorblind, so her dad. And my father, so her grandpa on her mom's side, was colorblind. So turns out 3 of their 4 girls are colorblind. So you have colorblindness. You also have printing. If you submit a plot to a journal, a lot of them in the past at least have charged extra for color. So what if it doesn't? What do you guys do with journal articles to read them? Often you will print them out. How many times do you use color to print out?
Never. It's not even an option in my department.
Yeah. Photocopies. So you have to really think about color. You have to worry about color blindness, photocopies, black and white printing, journal publications. So it's very good if you're going to use color, like you have a red line and a green line. Don't do red and green because red-green colorblind is the most common. And you might want one to be a very saturated color and one a pastel lighter color so that when you copy them on a black and white copier, they are different grays. And it's even better if you can build in redundancy. So the red line is solid and the blue line is dashed. So you can still talk about a red and a blue line if you wanted to, but if you lost the color, you could talk solid and dashed and you could still distinguish the two. You could have I took a 3-credit class on statistical graphics. They now have 2 2-credit classes over in the math department. So we're going to learn how to do this in R. Okay. I think this is the last thing on here. Tables. So in this chapter, it talks about making frequency tables. So we use these a lot, and in SPSS they were really common. And there wasn't a really great command in R to make frequency tables, so Tyson added one to his package furniture. We're going to use furniture a lot. It's a great package, and it's on cram. So if I have a variable x and it has possible values 1, 2, 3, 4, and anything can always be missing, it will give you the frequency, the cumulative frequency, the percentage, the cumulative percentage out of the valid, and cumulative percentage out of the valid. This table is created by saying table F. F stands for frequency. He also has a lot of different tables in there we'll use together. Okay, so here's a bar chart. What do you notice about the bars? We already said they are separated, and we start at 0. And this one is a histogram. The bars usually connect. Now sometimes we can have a gap. If there's no one falls in between there might be a gap. But it's not like regular interval gaps, like evenly spaced like this. And histograms, again, should start at 0 because we're looking at the percentage or count in each of those bins along the axis. Now, bar graphs we make when we have categorical variable. Histogram we make when we have a continuous variable. Okay. In this chapter on the homework, you're gonna have questions that say describe the distribution. I can guarantee this is definitely gonna be on your test. You'll be given some information about a variable, either a plot or some summary information, something, and you're gonna be asked to describe the distribution. What does that mean when we say describe the distribution? That means the values or the data points, we wanna know how they are scattered. Specifically, we wanna know about the center and the spread. Yeah.
So you mean frequency distribution?
Well, what if I said, what's the distribution of scores on the test like?
You could talk about skewness, whether they're
Skewness,
normally distributed.
Kurtosis, is it symmetrical?
Yeah.
Is it 2 modes, 2 humps? Do we have the failures in the proficient group? Or is it 1 group hump, unimodal? We could talk about the center. Where was the average, the mean, median, or mode? And we could talk about the spread, the range. So that's what we mean when we want to know about distribution. For continuous variables, so like scores on a test, like points, we would want to know what's the general shape. Are there any outliers or exceptions? What are the modes or the peaks? And what's the center and spread? That's chapter 3. And we usually make a histogram for a continuous variable if we want to look at the distribution. If it's a categorical variable, avoid the pie chart, but make a bar chart, and you can compare the percentages or counts. Like if we had a question about major, you could say over half the class were psychology majors, and about 15% were, so you've got to describe the size of the groups relative to each other. Or you could say there were 5 majors that all had about the same breakdown. That's called a uniform distribution, where all the groups are about the same. Question?
No.
No. So that's what we mean when we say describe a distribution. Keywords are symmetrical, unimodal, bimodal, skewed. I don't take too much in about kurtosis. Okay, we're going to go on to Eno's data set. We're going to use good old Eno's data set. So this is out of the back of the book. So we've already seen how many majors are there? 5. What kind of variable is major? Categorical, specifically nominal. What about coffee drinker? What would you call that? It's categorical, not continuous, in this definition. Is it nominal or ordinal?
Nominal.
Ordinal.
Oh, which one?
Well, one's not better than
It's
the
nominal.
It's nominal.
Or just
It's
nominal, yeah.
Some is more than none. This is a kind of an interesting, when you have only 2 levels, we usually just say it's binary. Because there are 2 groups, and order may or may, like yes and no. Do they have an order? Kind of. They're separate ideas. So usually we don't say ordinal or nominal. We'll say just binary because there's 2 groups. Because it's kind of in between. Phobia. What kind of variable is phobia? It's a score between 0 and 10. A whole number. Is it continuous? Or is it ordinal, categorical?
Ordinal.
Ordinal, but you said continuous. Do you want to argue continuous?
Well, because you can still pick numbers in between each number. And
In
it's
this one,
still-
they had to put a whole, like
A
with a
whole
bubble sheet,
number.
they had to do a whole number.
I think it's still continuous.
Still think it's continuous. What about the underlying concept of phobia?
Maybe that is continuous.
It's
That is
levels.
continuous, from none to more. But the way we've measured it, we've kind of, by necessity, discretized or set different levels. And so it's kind of, the idea is continuous, but we've measured it kind of at these ordinal levels. Are they interval, though? Not guaranteed, but we're gonna probably pretend like they are. So this is kind of a Likert-ish scale. And usually in real life, these are more common than we would like to admit. And we usually will treat them if they're continuous if they have more than 7 or 5 or 6 levels. Now, I say ish, there's no hard fast rule. But if we have 10 levels, we're usually, and that's dangerous to say this, usually safe to treat it as continuous. So yes, technically this is an ordinal scale from 0 to 10, but we're probably going to treat it as it's continuous. If you wanted to look at that distribution, would you, right now, would you choose a bar chart or a histogram?
Histogram.
I'm hearing histogram. Anyone want to say bar chart? Both of them would actually probably be okay. I would probably choose the histogram because it is probably going to be treated as continuous because we have more than 5, 6, 7-ish levels, like out to 10. Now, what if we'd only had it as a 4-point scale? Probably go with a bar chart and treat it as categorical. Probably. That's the fuzzy middle ground. So I like to say statistics is more of an art than a science. There's a lot of times where it's kind of a subjective kind of middle ground. We fall in a lot. Yeah.
So something that you said is like really sinking in. The subject that we're measuring can have a more continuous nature, but it's the units we're using to measure.
Yeah. The thing we're trying to measure is continuous, but the way we measure it forces it to be a whole number because of the measuring tool. A lot of times when we ask someone's age is continuous. You're getting older every second, but how do you usually report age? Your last birthday number, right? How many years you've completed. You don't say, I'm 12.37, I'm 42.39. Even though age is continuous, we usually report it as a whole number. It's discrete or discretized in units, even though it is a continuous thing. If we were only looking at second graders and we asked them to report their age, what would we probably get for second graders? Does anyone?
6 3/4 or something.
6 3/4. And second graders might tell you that. I'm 1 month, I'm 6.9, I'm 6 and 11 months and 3 days, that's how they are. But you might get only 6 and 7. Can you treat that as continuous if you're only looking at 6th graders? Probably not safe to treat age as continuous for 6th graders if you're asking whole age, because you're probably only going to get 6, 7, and 8. Only 3 values are probably going to come out of that. But if I ask age of grad students to the whole number, we'll probably get at least a 10-year window, right? So we might be able to treat that as continuous. So it depends on your sample and who you're looking at. Okay, so here is, I'm calling this data clean, but on the last assignment, I think we called it Eno clean, right? So you take your data set and you pipe it using the furniture package, the function table F, and then you put the name of the variable that you want to make a frequency table for. So I think you have to do one almost exactly like this on the homework for homework 2.
Yeah.
So you put the name of the data set, type it in to furniture table F, and then in the parentheses, you put one variable name.
Wasn't working for me.
Now this one says data clean. Do you have data clean in your environment, or is it called Eno clean?
No, data.
The data, you put the text at the top of this assignment
Oh,
already.
do you guys
and
have it
it's
open?
called data clean.
Yeah, it's called data clean. Have you run those chunks above?
Yeah.
And it's still not running?
No,
So we should pull up homework 2.
Let's pull up homework 2. Yeah, that's a good idea. So assignments. Mine's not sorted like yours for whatever reason. I have to scroll down here. So homework 2. Okay. So for the homework, I've done some of the work for you. So this first chunk is just setting some options. The second chunk here is loading some packages. So we have the Tidyverse and Read Excel that we've loaded before. Now I'm also loading the furniture package, and Tyson wrote that, and I've helped them. And Emily Brignon, who's now gone, she helped with that as well. She's graduated and she works at the VA. And then the psych package. It has a lot of nice tidbits. So you need to make sure you have all of those. And those should have all been on that list we installed on the first day. Problem with that? You good? Okay. All right, so here I have done, see this chunk? Looks a lot like the last chunk on our last homework, right? So I'm gonna run all that, and this time I've called it data clean. I don't know why I changed the name. Okay, so if we wanna make a frequency distribution for data, major F, we would say data clean, and then I'm gonna pipe furniture, make sure you spell it right, because that's the problem with me, table capital F, and major capital F.
So what if mine had an error right away, like right when I pulled it up?
Is Eno's data set, the Excel data set, saved in the same folder? That's the first thing. Should be.
Line number 99.
Yeah. Did Eno's data set? Okay.
Oh, that's the
So
previous.
So go up. Do you run this chunk?
Oh, you have to run that.
You always have to run the chunks above.
That should
Oh, and then there was a second chunk that you're reading in the packages.
So I should have just
Done. Run all above. Now, yep. Now, yep. You've got to run all the chunks above. That's
Mine
just
did
right.
it, but it showed red on the side. How
So,
about
it's already there.
it did it?
Alright, so in line number 99, it should. Here, put your-
That is really weird. You
Alright.
might want to look at that after class.
Alright.
Wait. Oh, yeah, that is. Okay. Notice under major F, it isn't saying 1, 2, 3, 4, 5. It's actually saying the labels that we had assigned. Now, if I had done major with no F on the end of it, that's the original major variable. The original major variable, MAJOR, had numbers 1 through 5. But if I do the name of the variable major with the F on the end, that's the one that has the labels attached. Which one would you rather look at a frequency table for? Are those labels nice to have? Oh yeah. Okay. What do you guys think? Frequency tables, easy or hard in R? Pretty easy. How much coding do we have to do? Is that a lot? Would you like to do this by hand? Take those 100 lines and count up how many of each major there were? How likely are you to make a human mistake? I'm guaranteed. Okay. All right, back to our slides. There we go. Okay, so here's phobia. Frequency tables we usually do for categorical levels. So 0 to 10. This one I'd say, can we treat this as continuous? Well, it's got a lot of levels and they're all being used. So continuous, like it's continuous, might be good. Okay, we ready to make your first plot in R? Fancy dancy? Okay, we are going to use a package called ggplot2. Now ggplot2 is loaded by the tidyverse. So you've already have it active even though we didn't say load ggplot2. First thing everyone says is why 2 G's and why the number 2? The 2 G's stand for the Grammar of Graphics, which was a book written by Edward Tufte who set down a lot of basic rules that, and he did it. I have like the second edition of the book, so great, in my office. It's like a classic. It's like yellowing because the deck is old. But back when they did graphs by hand, he set down the Grammar of Graphics, the general rules about plotting statistical and quantitative data, and it still is like the holy Bible of visualization. So ggplot, the 2 G's because it's Grammar of Graphics, the number 2 because before this, Hadley Wickham, the author of this package, made the original package called ggplot. And it worked kind of like having the pipe, but the pipe didn't exist yet. So it didn't catch on and people were confused with how to use that package. So he made the second version of the package and called it ggplot2. And you layer the plot by using the plus symbol. So we're going to make our plot, each layer of the plot, the Grammar of Graphics says you layer things onto your plot, like you start with your axes, and then you layer dots, and you layer lines, and then you layer labels, You layer your plots with the plus symbol. Now, Hadley Wickham has said this is one of the biggest mistakes of his career, because now that we have the pipe, he should have stayed with the way the original ggplot package worked. But it's now obsolete, so we have ggplot2. There's your history lesson. Okay, so we're gonna build layers, and we're gonna say, first we're gonna say a ggplot, and then we're gonna say the aesthetics. We're gonna use the AES abbreviation for aesthetics. This is where we say what the variables are that we're gonna use. And then we're gonna layer geoms. Geoms are functions that make parts of our graphs, geographical features of our graphs. We're gonna do geom bar and geom histogram today. Later we're gonna learn geom point and geom line and geom box plot, and they're all geom underscore something. These are parts of our plot. So guess what geom bar does? Bar chart or bar graph. Geom histogram makes a histogram. Okay, you ready to go? We're programming. Here is how you would make a bar chart. Again, we're gonna always start with the name of our data set. We're gonna pipe it into ggplot. Inside the ggplot, we're gonna set our aesthetics, which is where we say which variables we're worried about. We're gonna plot. So our aesthetic here is we're going to use, this one says major without the F on the end, so it's doing 1, 2, 3, 4, 5. But you could do major F, and then it will actually put the names of the majors down here. And then this is when I've been away from R and I come back, this always catches me unaware again. We use pipes to connect all of our steps until we say ggplot. Once you go into ggplot, you connect with plus. And I guarantee you'll put a pipe after you say ggplot and it won't run, and you'll look at it forever before you find out that, oh, the pipe should be a plus, because I still do that once in a while.
So what line do we put this on?
All of this can be on one line, or it can be on 3 lines. R doesn't care. I like to put one thing on a line because it helps me find mistakes faster. So start with the data set, pipe it down. We're going to do a plot. So we say ggplot, aesthetics, the variable name is major or phobia or whatever variable you're doing. And then you add on a layer of geom bar. Okay, I'll come look at it. This needs to be, you don't put anything like in the art geom bar. No.
Yeah.
Okay.
I just went
So
down
like
to the
line
next
111 is correct.
Yeah.
Okay.
Thank you so much.
Now, you don't put anything in the geom bar. See, after geom bar, you don't have to put any additional elements in there. You have to have the open and close parentheses, but leave them blank. We're just going to let it do the default.
That's why I just hit it right.
Oh, this says continuous var. You've got to replace that with the name of an actual variable. So table F stays, that's the name of the function, but inside the parentheses, it actually needs to be the name of an actual variable. That's just a placeholder. That's not a real variable name. Yeah. Yeah. Yes, I am. It's a different recording than I use, because that other one crashed and burned. I'm trying something new. So yeah, so there is no counter. Good catch.
Okay.
Yeah. Because I told you to watch for it.
Anyways,
Yeah.
Lightsabers.
Yes.
I really need that.
Yeah.
No, it was major, that's what.
For the labeling of like the X and Y axis, is there an easy way to change that so that is that out of
there
the
is.
scope of today?
That's outside of the scope of today.
Okay, then don't worry about
Yeah.
answering it.
So right now, it'll say the name of the variable down here, and it'll say count over there. You can change anything. This is the beauty of R, is it has good defaults, but one of the defaults is to put the variable name on the x-axis, and sometimes you want it to say something different because your variable names are sometimes gibberish. You can change that, but I don't want to take class time. That's fine. But if you want to stay after, I'll show you. Okay, because it's very easy. Okay. Okay. Guess how we would make a histogram?
Histogram.
All we do is geom histogram. But in order for it to be able to do a histogram, that has to be what kind of variable? It's gotta be a continuous number variable. If you try to put a factor there, it will complain, because you cannot make a histogram of a factor. You only can do a histogram of a numeric continuous variable. Like, have you run everything before? Yeah. No. It was not able to find the data clean not down. There you go. Okay. Yeah, so for a histogram, here I did phobia. Is that really a histogram? Does that look like a histogram?
It's a bar plot.
It looks like a bar plot, but I made a histogram. This is a problem with all histograms. How many bars should you have and how wide should they be? ggplot is great at defaults, but it's not perfect. It has chosen to make those bars half a unit wide. So here is from 0 to 0.5, 0.5 to 1, 1 to 1.5. So it ends up having no one in half of those bars. So that's the default behavior, that in histograms, the default choice of bins are the bar widths, is not always what you want. So you can override that in one of two ways. You can choose. You can either choose to tell it how many bins you want, or you can say how wide you want the bars to be. So this is how you specify if you want to change how many bars there are. I think it defaults to around 15-ish. It has some complex way it tries to pick the best thing, but it's not always great. So inside the geom histogram parentheses, we could leave those blank and it's going to default choose how many bins, but we can override it by saying bins with the S at the end, plural, equals, and then you can put any number you want. You could put 157. You could put 2. And then it's going to make that many bars. 8 probably doesn't make sense here, but I'm just showing you, you could pick a different number.
If it doesn't automatically bump it over, are you doing something wrong? Like how the ggplot starts partly under data. So like, that's perfect.
Go up to the next line. Hit enter. Oh, it's not doing it. No.
Okay.
Does it need to be aligned that way? No.
Okay.
Remember in R, as long as you have one space, it doesn't care how many spaces you have or if you put enters or not. Again, you can put all of that on one line. Doesn't care. But I like to put one thing on each line so that I can find mistakes. Because I make them all the time.
So when the assignment asks about R's choice on class intervals, is that
Yeah.
what it's talking
Yeah,
about?
so
that it
R
does
chooses
the-
how many and how wide to make the bars. And sometimes it does a pretty good job and sometimes it sucks. So the homework asks you to comment about that. And the answer to that comment, you actually type into the Canvas assignment. There's a place in Canvas for you to type in. It was really sucky. It chose too many bars, so half of them were empty.
So when it says like in the write-up discuss,
Yeah,
you don't
the
mean on
write-up-
file, you
The
mean-
write-up used to be paper write-up, now it's the Canvas quiz. I need to change that language
Okay.
now.
So
I
don't
was writing
put
it in the R document.
Yeah, don't write it in the R document, it goes in the Canvas.
Okay.
Yeah. There should be. I better double check on that. There
I'll-
should.
I can look.
I think it's there. Okay, so you can either say bins equal a number, or you can say bin width. Now this is bin singular width. It's bins plural for how many, or bin width to say how wide. So I want them 5 units wide. Or the score was from 0 to 10. Yeah.
So I'm just looking at the
Homework?
homework
Uh-huh.
for C2 where you want us to do bar charts for like it says
Yeah.
bar plot, you want us to do bar plot.
Bar plot. Because histograms do a histogram. Yeah.
Okay.
I tried to give you good
Okay.
notes. Now, all of the homework is what Barry's green book has his students do in SPSS. I'm just translating it into R and giving you some more hints for R. Okay. So bar charts are pretty easy. You just say GM bar. But histograms, you may need to put bins equal or bin width equal to make it look better. Now, is 3 bars probably appropriate for this one? That's probably not a good choice. Is this a good choice? No. If they're all separated, probably not a good idea. This might be okay. I mean, the thing with histogram is there is no one right answer for how many bins or how wide they should be. There's no one answer. That's why R can't automatically do it good every time. So you kind of have to play with it a little bit. You want to find a happy medium between too many and too few. Now, if I did bin width 4 here, what does the shape look like? How would you describe the distribution?
Pretty normal.
Fairly normal, fairly symmetrical. The average or the mean is right around 30. This is the math quiz variable. The range is from, not quite 0 to 50. You can describe it with words. To describe the distribution requires you to type some words and or multiple sentences.
So you're just describing what it looks like.
Yeah, what does it look like? Yeah. As far as center, spread, shape, are there any exceptions? No, it's a pretty smooth, almost symmetrical, one peak hump. Versus, how would you describe this one? Skewed.
Positive.
Yeah, is it positive skewed, negative skewed?
Positively.
You say where the tail is, the trickling off part. That would be positive, or you can call it the right skewed. We usually say positive skewed. You could also say it's unimodal, with most of the values falling below 5, and a smaller peak around about 8 or 9-ish. It's going to take some words to describe this.
Wouldn't that be bimodal?
So yeah, you could say it's bimodal. Now, there's not one right way to describe a distribution because it's a little bit complicated. Okay. Now, sometimes we want to make a histogram separated for different groups. So here I've got the math quiz variable, and I want to make one plot for coffee drinkers and one for non-drinkers. 2 separate plots. You can do that. This is one. There's like 5 ways you can do this. One way you can do this is saying facet. So the first part's the same, but now I've added this facet grid. Facet makes panels. And it does it in a grid because you're going to have rows and columns. So facet underscore grid will make, instead of one plot, it'll make separate plots in a grid. And then inside that parentheses, you can have a name of a row variable and or a column variable. And in between them is the tilde. If you choose to only have 1 row and 2 columns, you would do a period, tilde, then the grouping variable. In this case, it's coffee up, because these are the not coffee regular drinkers, and these are the regular coffee drinkers. Notice, where does this text come from? Those were the labels we attached to the coffee F variable.
They have separate x-axis, but the same y.
They have the same y-axis, and these x-axes end up being identical to each other. This is called the law of small multiples. So in data visualization, if you have panels, the axes should be identical so that you can make comparisons one to the other. So this one, I have facet grid dot tilde coffee because I don't want it to break it up into separate rows, but I do want it to break it up into separate columns based on coffee drinkers. So this is making them side by side. How would I change my code if instead I wanted my plots on top of and below each other? You would change the order of the period, which means no variable, no splitting up, and coffee. So if I take those on either side of the tilde and swap them, instead of being side by side, they're going to be paneled up and down. So, like that. Sometimes you want them side by side, sometimes you want them up and down. what's good about having them up and down on top of each other? We can compare where the centers are. Are they shifted from each other? What would you say about the coffee drinkers? This is math quiz. This is fake data, by the way. But how would you interpret this? Coffee drinkers' math quiz scores are
Lower.
look like they might be slightly lower, but the non-coffee drinkers looks like there's almost a bimodal distribution. But the mass is falling with slightly higher scores. So you can do visual comparisons. Now that comparison, how easy is it to make that comparison side by side? A little harder to judge that when they're side by side because they're squished in. And where's this center compared to that center? It's a little harder to compare them when they're side by side. So if you want to compare the centers and the spreads, it might be easier to do if they're on top of each other instead of side by side. So facet grid is one way to panel your plots by dividing up your sample. And the variable name you put in here is what it's going to divide by.
But aren't there two variables?
Yes, there are two variables. Where's math quiz? Where's that variable? That's our x-axis. What's the other variable? Coffee drinking. Where's that variable? Top or bottom panel. What's the y-axis? The frequency count. How many? So in this bar, say that's one high. What does that tell us? There is one coffee drinker that scored between 10 and 15 on the math quiz. And there are two coffee drinkers that scored between 15 and 20. Do you guys want to make these by hand? Heck no. Okay. Oh, we're 1 minute over. This is the last thing I have to show you to be able to do the homework. It's deciles, quartiles, and percentiles. You use the same command for all of these. So, a little bit more code. It's only 3 lines of code. What do we start with? We're always starting with the name of our data set, and then we always pipe it into a step. Are you finding that that's like every time we do anything, right? We start with the name of the data set, we're piping it in. This time we're going to use dplyr pull to pull out one of the variables. So you pull out the name of one of the variables. So I'm going to look at the stat quiz scores. So I take my data set, pull out one variable, and the command is quantiles. And this is out of base R, so I didn't give a package name. And you say probs. Anyone guess what probs stands for?
Probabilities.
Probabilities. What are the probabilities? What does that C in front of a parentheses do?
Vector.
Makes a vector, or it combines or concatenates a bunch of numbers together. So we've got 0.10, 0.20, 0.30, 40, 50, 60, 70, 90, up to 90. What did we get out of that?
Percentile.
These are there are some percentiles, we would call these deciles because there's 10 of them. So these are the 10 deciles. Sometimes, so what would someone have to score to get in the 90th percentile? 8.1. If someone scored 7, what percentile would they be in? 40th percentile. Now there's only 100 here, so some of these are identical. How would I change this if instead of the deciles, I wanted the quartiles?
0.25.
0.25, 0.50, 0.75.
So if you get an error saying that factor X is missing.
Let me look at that. I just want to do this before we go. Okay, but I'll look at that. So in this one's the math quiz. You guys remember what was different about the math quiz variable? There were some NAs. Remember, 15 of the students hadn't taken that math quiz and they didn't have a score. So if you try to do that decile code, you're going to get a mistake. You're going to get an error out. It's going to say, can't do this because, let's look at the message. It says, missing values and NANs, that's not a numbers, not allowed. if na.rm is false. This is one of the defaults for this quantile. The quantile function, if you have a missing value, it freaks out like this. What do we want to do about those missing values, do you think? Remove them and ignore them. Let's just do the deciles on the complete data. That seems reasonable. That's not the default behavior, so we have to put an option in. And the option we need to change is an option that's in a lot of functions. It's called na.rm. What was the na to stand for? Missing. That's our missing stand-in. And rm stands for remove. So do we want to remove missing values? Yes. So we say true on all caps. So when you add that na.rm equals true, it's going to throw out the missing values and do the calculations on the complete data. Okay. And then here is, if you wanted to do quartiles, you just, in the probs equals. Now, make sure it's 0.25, 0.50, and 0.75. What do you think is going to happen if you put 25, 50, and 75 without the decimals? You'll get an error. Now, what if I wanted to find the 69.5 percentile?
0.695.
0.695. You don't have to put nice numbers in there. You don't have to put evenly spaced numbers in there. You can put any old numbers between 0 and 1 that you want. And I think the last one on the homework asked some really funny number percentiles to find. So if I want the 90th percentile, the 5th percentile, you can just choose any old ones you want. And that's, I think, all that's on homework too. So we had frequency tables, bar plots, histograms where you have to choose bins and bin widths, baby facets, put them side by side or up and down, and percentiles, deciles, quartiles. The polyogive, don't worry about that.
Okay.
Yeah, we won't worry about that. Yeah. There's a lot more in the book than what we cover in class and what's on the assignment. That's the stuff that's going to be on the test.
Oh, that's helpful.
Yeah. So I've got to make it so it'll show you your homework.
So if we study the slides that are in every lecture, we should be good for the test?
Yeah.
Okay.
But what is the bulk of your grade? Is it the tests? No, they're like just checks. And the test is open notes, I was going to say homework, but the homework's on there, so not really. So it's just open notes. So you can print out your summaries. You can print it, copy anything out of the homework you want. I will never ask you to program on a test. Never. That's mean. That is just evil. I might give you a picture of output and ask you to tell me about it, tell me what it means. Like right now, I could give you like this decile one. I said, to be in the top 50 percentile, what should you score? 30. I could give you a picture of a histogram and ask you to describe the distribution between the two groups. I'm not going to ask you to write the code on the test, but I might give you the output and ask you to describe, explain, or interpret what you're seeing. And that's true for the whole class. Okay, we're going to see if this recording works. My test works, so let's hope. Fingers crossed.